Hello, everybody, and welcome to the second part of this continued deep learning crash course. And today we are going to be discussing the few elements of, basically PyTorch and PyTorch-Lightning as the frameworks that we are going to be using moving forward. So, as you all know, Andrej Karpathy has been contributing to computer vision over the past 8 years quite a lot, and this is just a tweet that he mentioned about PyTorch, which I consider is pretty awesome. Anyway, moving forward, why should we use PyTorch? Well, I'll just mention a few features of PyTorch, which are like these dynamic computation graphs, which were never introduced before. And what that means is you can define the neural network as you are going, and it doesn't have to be in a fixed structure. So, like, you do an X operation and then you continue to do a Y operation. And this is a capability that TensorFlow 2.2 hijacked from PyTorch. Again, it's very comparable to NumPy, so it's pretty easy to use, highly flexible, and it just uses a innate Python debugger, which is pretty amazing to use, which is not supported by TensorFlow natively, at least until 2.0. And basically, it's just awesome. I'll keep it at that. Moving forward, well, why do we care so much about these frameworks? And one of the major reasons why, as you guys can see over here, is because writing neural networks in Scratch just sucks. That's it. Like, it's that simple that neural networks are too hard to write, as you can see over here. And that's why we need these frameworks which do these gradient based updates and these auto differentiations. And we have to be away from those things, and we can actually, work on the applications that we want to develop through them. That's why. So as you can see, the same code that was for a neural network is converted to PyTorch in these lines, and that's it. So as you guys can see, all we have to do is define the network over here in the few lines that you can see, like it's less than 10. And then you have to just write a loop to train the network. That's about it. So as we move through this, let me just walk you guys through this. So as you guys can see, here we have defined a neural network module, which is a linear layer with input size and a hidden size and the number of classes. And then we add a activation function, and then similarly an output layer. And then we write a forward pass through it. I'll obviously help you write newer networks throughout the course. So moving forward, then we initialize it, we set the criteria, and we fetch the optimizer. Followed by this, we load the data through a data loader, and then we train it for epochs, in number of epochs, and in every epoch we iterate through the entire image and their labels. And obviously we are just moving these to the device. That could be a CPU or a GPU. You can train the neural networks on CPUs or GPUs, as we know. And then we generate the outputs, we create the loss, and then we do the optimizer with the backward pass and just move forward. So it's pretty simple, it's pretty standard. Moving forward, now we talk about PyTorch-Lightning, in which, basically PyTorch-Lightning is a wrapper written on top of PyTorch, in which you don't even have to write a lot of code. It's just made to keep your life simple. Again, this was brought to us by the great man himself, William Falcon, and it's just amazing. It has a lot of things that you have to usually code up. For example, as we see, saving best weights, mixed precision training, automatic logging, and the list goes on and on. So that's why, again, these are all the features that are available in PyTorch-Lightning. I would love to go through this, but you can just pause the video and look at all these features that are available within a single function. So that's the best part of it. Now, that's it for today. So last time we had a quiz which went like this. So what would happen? between a deep convolutional neural network and one thick boy? So the answer is you have to take a look at single pixel attack. It's a paper that's been written in 2016, and please feel free to Google and read through the paper's journey about how a single pixel could fool an entire trained neural network. That's it for today. Also, guys, if you like the video, please make sure you show the video some love by clicking the like button, sharing the video with the people who could benefit from this, and subscribe if you haven't already. And please let me know in the comment section again, what would you like to see in the future? If you really like this content, I would like you guys to show some support on Patreon. And until then, stay awesome.